Now let's talk about the uniform distribution. Uniform distributions are approximately the same throughout. And so when we saw a graph of it, uniform distribution looks something like this. Okay, and here is the formula for the theoretical mean, and here's for the standard deviation. Now, we don't have to understand the math behind this. These are given to us, and then we can just plug these in to calculate it. The notation is up here, and we can read that a couple different ways, but we'd read it as x is uniform from A to B, where A is the lowest value and B is the highest value of x. And then for the probability of x is between C and D inclusive, and this is the probability of x is between C and D, equals f of x times D minus C. So let's go ahead and look at an example. Okay, that's all the math written out. Here's an example. So the data that follow are the number of passengers on 35 different charter fishing boats. The sample mean is 7.9 and the sample standard deviation is 4.33. The data follow a uniform distribution, so we know it's a uniform distribution where all values between and including 0 and 14 are equally likely. State the values of A and B, write the distribution in proper notation, and calculate the theoretical and mean and standard deviation. So we know that x is a uniform distribution between 0 and 14. Okay. So the values of A and B. A is 0, B is 14. It's the highest and the lowest. Write the distribution in proper notation, that's this, and then calculate the theoretical mean and the standard deviation. So that's done down here. We just plug it in. A is 0, B is 14, so we get the theoretical mean of 7. We do the same thing, we just plug in our values and plug it into the calculator, and we get 4.04 for the standard deviation. And here you can see they've just written the answers right there. Okay, here's another example. A distribution is given as x is uniform from 0 to 20. What is the probability that x is going to be between 2 and 18? Find the 90th percentile. So the notation for the uniform distribution is this. We have our f of x is going to equal 1 over b minus a, where a is the lowest value, b is the highest value. And then we have our probability information here. So let's go ahead and find the probability that x is between 2 and 18. So let's start there. So first, we know that this distribution goes from 0 to 20. So we know that that's 20. We know that this starts at 0. We need to find this value here, f of x. And so remember, we are looking for an area, and it's the area in between here. So let's go ahead and calculate f of x. So f of x is 1 over 20 minus 0, which is just 1/20th. So this is 1/20th. Now we can go ahead and find the probability that x is between 2 and 18. Remember that when we find the probability, it's the area. We are looking for the area here, which is base times height. So it's going to be, the base is 18 minus 2 times the height of 1/20th. So if you multiply that, 18 minus 2 is 16 times 1/20th is 16 over 20. And if you calculate that as a decimal, it is 0.8. So you would have an 80% probability of having an x between 2 and 18. Now it wants us to find the 90th percentile. So this requires us to do just a little tiny bit of algebra. So we're going to set up the probability between A and some unknown D to be 90% or 0.9. So the way we're going to do this And we have this equation up here that we are going to use. So right here is what we will be using. So we will set up this equation. We need the probability to be 90%. We're looking for the 90th percentile. We plug in the information we know. F of x is 1 over 20. And then we are going to multiply that times d, which is our unknown, minus c, which is 0. So this gives us d minus 0 is just d, so 1/20th times d is just d divided by 20. Here's where the algebra comes in. To get d alone, we multiply each side by 20. So that cancels out the 20s on the right. We are left with 18 equals d. So the 90th percentile is at 18.